All right, folks, let's dive into a journey into making an alternative to VS Code remote development. For those of you not familiar, VS Code offers a way to edit code remotely, but we can do it better. We can do it smarter. But first, who am I? So my name is Chip Sinkbell. From the introduction, I'm a solutions engineer as of yesterday at Meta. And a little bit about me in terms of background, a couple of things I've done that may be of interest that are open source related. I was one of the main writers of Apache Tori. It's a IPython Jupyter kernel for Apache Spark. I formalized a specification for VimWiki. If you've used VimWiki, love VimWiki. It did not have a specification compared to, say, Common Mark or other Markdown dialects or whatever. So we've got one now. I built a tool called the Scala debugger to debug Scala. That got rolled into an organization called Enzyme. It was kind of like the precursor to do language server stuff before language server protocol existed for Scala and Java. And most recently, created Distant and what we're talking about today, distant.envim. So as a precursor, we're going to be talking about a plugin that's been built for neovim. A lot of the concepts I'm going to run you through in terms of how this is done can also be done through Vim. I personally found it easier to use Lua than Vim scripts. That's why I went with a neovim plugin. Before I go any further, though, I got to have this little blurb. Any views, opinions, or works represented in this presentation are solely my own and do not represent my current employer in any way. All right. Let's see in action. So I am going to... I've got a Vim open here, or rather neovim. It's actually open to my dot files. I'm just going to give you a quick demo of what it's like to use distant.envim to edit files remotely. So I've actually configured a couple of servers here. I'm going to load up, if I can remember the IP address. Let's see. Oh, yeah. So I'm going to launch a server with this IP address. This is a Linode instance. And when I do so, it's going to ask for a password for that user. I'm going to enter it. And I'm now connected to that server. So if I do a session, I can see what I'm connected to. I'm connected to this remote server, 45794951. And I can open up a directory on that server. So I can go to, I believe on that machine, it's a Debian instance. And boom, we've got this home directory for a user called Sinkwich. It's got a file. It's got some other files. If I open up hello.txt, it's a remote file with some more content in it. Try even more content. And I can save it. All right, so this looks like I'm just editing files locally on my machine. When I do things like saving and navigating, that's what actually talks remotely. If I go, and I need to remember this IP address because I've already forgotten, 457, I'm not going to remember that. Hold on a second. Let me just open up another one of these terminals. And I SSH in. Oh, good. I was smart enough to actually have this in my history. I SSH into this remote machine. I am now in SSH. You can see the exact same files, bin hello.txt, so on and so forth. I cat it out. Boom, there's the content. So seamlessly, we're able to use Vim, neovim, to edit content on the remote system. This is a Debian system. From the comfort of my local machine. Got all my plugins locally. I'm not having to install anything other than programs I want to run on that remote machine. So that's it in a nutshell. It can do some other things like engage with language servers. It's got a bunch of other stuff underneath the hood that we'll talk about. I just want to give you a quick preview if you hadn't seen the videos I'd already recorded. Now, you're looking at this and you're saying, why did you build this? Why would you even need this? Why don't you just SSH in all the time? There are three main reasons I did this. So one, I work with a lot of servers, and copying my dot files to every single one of these servers is a pain in the butt, honestly. I cannot stand doing it. I've done it with so many servers. I lose count of what dot files are synced where. You want to update dot files, it gets to be a pain. So one, avoid dot file replication. If you only have your dot files located on the machine you develop on, and then you just do the remote stuff that you need to talk to elsewhere, but all of your main UI plugins like Telescope and everything are local, you don't have to copy them over. Lag. So if you're using a server and you're going to SSH in or Mosh or Eternal Terminal or any of those things that let you go to a remote server, if the connection's good enough, lag's not a problem. For me, though, with a lot of the servers that I work on, it sucks. I'm trying to jump around a file. I just want to type some text, and I'm getting some lag, and it really just breaks me out of my flow, out of the zone when you're writing some code. With Distant, you aren't sending network requests whenever you type. You're only doing that when you write a file, read a file, do some navigation. It's much more controlled as to when you're talking to the remote server. So we're removing some of that lag when typing specifically. And lastly, there's some plugins that exist out there that kind of do this in certain ways. And I'll touch on those in a little while. But I once that gave me a little bit more of a tighter editor integration. And that's what Distant does. It lets me do things like bake in my SSH prompts into neovim directly and do some other things like have the editing experience be more native and have some of the program execution experience be more fluid. So that tighter editor integration, that was key for me as well. All right, so I've given you this kind of like who I am, and I've shown you a little bit of a demo of what it does, and I've talked through like some of the reasons why I wanted this thing. Let me give you an idea of what we're actually going to be talking about specifically related to the plugin. So we're going to run through specialized buffers, what those are, why that relates to distant.envim. I'm going to talk a little bit about outsourcing to external processes and how neovim, this plugin for neovim, does that. And lastly, this is one that I think you'll find interesting especially, is using Rust in neovim. And I'm not talking about like a remote process that you talk to. I'm not talking about like one of the classic things that neovim offered. This is actually using Rust to interface with Lua so that the plugin you're writing with Lua actually is able to use that Rust directly. All right, let's talk about buffers. I think you had a great talk about buffers, or you were having a good talk about buffers earlier. So this is probably going to be a review for you. If you look up buffers, windows, tab pages in the Vim help, you're going to get these definitions, right? Buffer, in-memory text of a file. It's supposed to just represent the text of a file. Window is how you view a buffer. And it's just an example, you can have multiple viewports of the same buffer. You can just have them jumping all around. And tab page, a collection of windows. So not too many people use tabs that I've seen, but you can have a bunch of windows and just jump over. I think a lot of people use tmux to do this where they have separate Vim instances. But these are kind of the three main concepts with Vim. It took me a while to get my head around these in terms of the buffer versus window versus tab page. So let's just look at, you got one buffer. Each buffer has a number associated. So we're just going to say this is buffer number 4. Got some open file, haven't written anything yet, so it doesn't have a name. If you run something like split, :split, you now have 2 windows pointing to the same buffer. It's the exact same thing, right? This is a refresher. That's kind of how it works. Windows can point at the same buffer, different buffers, whatever. And this is a refresher, right? So if I had a split and I have 2 different buffers I'm working in, one editing file A, one editing file B, maybe you have buffer number 4, buffer number 5. Here's the stuff to pay attention to. 1, you can have variables associated with a specific buffer. You'll find a lot of plugins use this to their advantage to store specific details that they need to maintain for each buffer. So if you're editing a file and you want to keep track of something for that specific file tied to that buffer, you can put a variable in there. They're always prefixed with a scope in Vim, which is b:. So in this case, they can have the same name. myvar on file A, buffer number 4, has hello. myvar on buffer number 5 for file B has world. So if you were going to say echo that out, you can get hello in one and world in the other. I think a lot of you already know that. You can just store variables and buffers. Did you know that you can also do buffer local key mappings? Something I did not realize at first is that not only can you do like these global mappings and try to have like file type specific, you can just flat out have a specific buffer have a mapping, right? So if I had normal mode and GH is the mapping, and if I was in buffer 4 file A and I typed GH, it would echo out hello. If I was in buffer 5, which is file B, and I did GH, it would echo out world, right? That's pretty powerful in terms of you can add unique bindings to each buffer. You can have really like auto-generated bindings and associate them with buffers. And you'll see this used in a lot of plugins. But you can do it yourself too. If there's some thing when you're starting like opening a file, whatever, and you want to attach certain things essentially as you're doing it, maybe not based on a singular file type, maybe on some other logic, this is a great way to do it. So I've given you a couple of those specifics about buffers, the last thing I want to cover is a buff type. You familiar with buff types? There's a bunch of them. When you open a buffer, you start thing. That's like the normal buffer. It's just, yeah, I'm a file. Deal with it, right? There's a bunch of other ones. And there are two specifically that we're going to care about with this plugin, which are AC write and no file. If you read some of these descriptions, you start to read them and you're like, that's not a file. That even says that this doesn't represent a file. So already the definition of what a buffer is, that it's, the file in memory, some of these already make that completely like thrown out the window. No file, that clearly means it's not a file. So that original definition doesn't even make sense. We're going to use some of these to our advantage, and that gets into specialized buffers. All right, so I've talked about regular buffers. We've looked through like, hey, we've got some buffers open, we're editing files, whoop-de-doo. What about specialized buffers? We're not just representing text files anymore. I'm going to give you a couple of examples. Any of you used calendar.vim? It's a great plugin. Does that look like a file to you? Not to me. That looks like a calendar. What about Telescope, right? Yeah, you've got like a preview on one side and you've got a list on the other. But collectively, does this look like a file? Maybe parts, a little preview, but overall, it's got a little bit of specialty to it. What about Dirvish or underneath netrw? You got a directory open. Depending on how you think about it, directories are also files. Especially on like Linux, Unix systems. But not what you traditionally think of when you're editing a text file. And navigating through that, that's like a whole other experience, letting you just jump around in your directory. So those were examples of buffers that they weren't a regular file. They were just straight up like, hey, I'm a directory. I'm a calendar. I'm just something that's not a file. And we're going to use that to our advantage with this plugin. There's also how things like netrw get away with how they do remote editing as well. But first, one last detail for you. I've gone over like basic buffer stuff. You can have variables, you can have key bindings. I've gone over different types of buffers. Last thing is a reminder, auto commands, right? What are those? Essentially, it's like your asynchronous events. Something happens in your editor, an auto command triggers, you can attach some code to happen with it. There's two that we care about, buff write command and buff read command. Both of these give you control over how a buffer responds when you want to write it and how a buffer responds when you want to read into it. We're taking over both of these because we want to control what writing and reading do versus having it being done to a local file. So what does distant do? All right, so we're back in Vim, or rather neovim. I keep getting them back and forth here. Back in neovim. We got some text here. We're like, great, I wrote a Lua function. It's the best one ever. It's the best written you ever find at the very moment, because that's all you're looking at. It's this one Lua function. All right, so at the moment, we want to write, and we're going to actually add a prefix. Normally, if you want to write this file, you do like :w hello.lua, or maybe you've opened hello.lua already. We've got distant : / in front of it. It's a scheme, like HTTP or SFTP or any of those type things. It's a scheme. You can actually use prefixes in your auto commands to trigger. So in this case, we have buff write command saying, hey, look, you're trying to write a file that has a scheme in front of it. So I'm going to take over and I'm going to control how writing this file works. And when we do this, instead of actually writing to a local file, we talk to a remote server called distant and we say, hey distant, I got this file here. Can you write this for me? Distant's like, I got you, and puts it on or into a file called hello.lua. All in some website, some server called example.com. This is not happening locally because we're controlling how write works. We're not letting it do local file writing. Same thing with reading. If you had an empty buffer and you did :E, editing a file, and you're going to load it into your buffer, and you do distant : / hello.lua, well, we've got an auto command that's looking for any time you're editing a file with that distant : / in front of it and saying, no, we're not going to read locally. Forget that. We're going to talk to this server, and we're going to ask it for what the contents of that file are. So that's what we're doing here. We do :E, we talk to the server. Server's like, give me the contents of hello.lua, and sends it back. And this is the core of how distant.envim works. This is actually the core about how other plugins like netrw work, and that they bind to specific schemas, or not schemas, schemes that are prefixed, right? So you may have used auto commands before for maybe file types. If you're like, hey, anything that's got like .rust or .js or .go or whatever, I want to trigger like some file type things, maybe a certain language server or whatever. This is using a prefix instead. So you can actually combine prefixes with suffixes and do all crazy sorts of things. But this one is specifically used to control how reading and writing work. What I don't show in these pictures are, if you were reading a directory, this exact same buff read command would trigger, but instead of getting a file, you get a directory listing back. And we'd actually load up a completely different buffer format. But anyway, I'm going to show you some code in a little while, but I just wanted to get through the basics of how this works, because this is a very core mechanic, is you're controlling how reading and writing works, and you're kind of changing how neovim works underneath in terms of how you engage with your content. All right, so we've covered one of the core concepts. Let's talk about outsourcing to external processes. It's something I think people kind of forget, because especially in the land of all these modern IDEs, you're used to the kitchen sink and even the whole house coming with you wherever you go. And when Vim or VI or any of those were around, they were much more used to farming out work to other programs and having simplistic design and having it being very goal focused. Like Vim is your editor, but if you want to do other things, you want to pipe out to those processes and then get the results back in Vim. So let's take one example, or rather a couple of examples, but we're going to have two categories. And the first one I want to talk about is outsourcing for short-term processes or single responsibility. I like to think of this as like if you're calling a function, but you're actually talking to a remote process instead to do something. So for example, you want to get the contents of example.com. Use curl to do this. I mean, you could write a whole plugin that tries to use Lua and uses like the libuv and tries to talk to like web pages, maybe try to deal with SSL some way, but you could just use curl. You pipe out the curl, you get the results back, you can put it into a buffer, and then it's done. You want to get the status of your repository you're in. You pipe out to get. You do a status, you get the changes, you're done. You want to search for a pattern in grep. You pipe out the pattern to grep, you get the results back, you're done. It's like a single purpose. And distant.envim actually uses this, especially specifically with curl and get and a couple others, to do those short-term single responsibilities. Long-term, this is as a recap here, right? What you're most familiar with, most likely for long-term processes you talk to from your editor, are probably language servers. Normally these will run locally. You'll be talking to them over standard in, standard out. You can do things like, hey, tell me what I'm hovering over, get some info back. Hey, what's the latest definition? You get a file location back. It's pretty straightforward, right? But it doesn't go away after you finish one request. It sits there and it's hanging out and you're talking to it all the time. That's what I consider a long-term external process. You're farming out all this work to something external, getting the results back and having them engage with your editor. Separately, and I'm getting a phone call, I'm going to hang up there. Separately, this is actually how distant used to work. We used to have a local process that would run on your computer, and for all the requests you want to make to the remote server, you'd first farm out to this local computer. Oh, I'm getting a Twitch back again. There we go. So anyway, you have this local program running. You'd feed like a request to it, like, hey, I want to read this file, and then it would go and ask the server, get the results back, give you the contents. You say, hey, I want to run a program. You'd send it to this local process. It would talk to the remote server. It would give the results back and feed it in. That's the old way. We're about to go into the new way, but I just wanted to clarify like this short versus long term, because we use both of these quite a lot. And when you want to build your own plugins, keep in mind you can do this. You can farm out to other programs all the time. All right, so what does distant do? Today what distant does is it actually uses things like curl and get to make installing that a certain part of a library a bit more straightforward. So we have this binary we have to download from GitHub, and we're actually able to use curl to ask GitHub, hey, like, what releases do you have? Select a release, and then use curl as well to download that release. And it's going to download it to your local machine, set it all up for you. Pretty straightforward. I would not want to have to write that directly in neovim if I could help it. So yeah, this whole install process is an example of farming out to curl. If you built from source instead, it would use git to grab the latest commit of our project, use cards as a Rust project to build it from source, and then copy the library over. But the idea here is keep it simple. If someone's already done the work to make something really easy, farming out to a process, pipe to it, write a little wrapper for it. You don't necessarily need to reinvent the whole world for every plugin. All right, so now this is I think one of the more unique aspects or weird aspects of this project, in that it's not purely Lua. It also has a Rust interface. So let's talk about neovim. Traditionally you'd have like Lua code that you're doing, like distant.lua or something like that, and that would be it. You'd have Lua. It would work with neovim. It would do whatever you want to do. But in our case, we have an extra piece. We have a shared library, and it goes neovim to distant.lua to the shared library, and back and forth and back and forth. So we got this extra piece. And for those of you not familiar with the concept of shared libraries, it's essentially you're compiling some code, and instead of being a program that you run, it is some code that then, once compiled, you'll load into other programs and be able to use that code again. And so in this case, we're compiling some Rust, and then we're able to load that into Lua. And I'll show you examples of what that looks like in a little bit. But how is this done? I want to give a shout out to a project called mLua. I think TJ has also used this. A couple other folks have also been exploring this. It makes it really easy to write Rust that then is able to be accessed and used from Lua. So you're using Rust, you're able to compile it down, and Lua knows how to read and talk to it. And I'm going to give you a very little quick snippet of code here. This is what it looks like if you want to write your Rust code. You have like a single method that you would define, and that's what you're going to import. It has to have the same name, so that distant_Lua. And then from Lua, this is what it looks like. You expose stuff that you want to have available from Rust, you require it, and you call it like you would in Lua. It's darn simple, at least in concept. But there are trade-offs here. So I mentioned I had previously had this whole thing where you talk to a local process and do stuff. If you do the Rust way, there is no external process. You're having Lua load in like Rust stuff and run like essentially the equivalent of C code. It's just essentially some shared library. And there are dangers. The biggest one is you can kill neovim from your plugin. If you write pure Lua, you're gonna have a hard time doing that. But if you have a panic in your shared library, neovim is like goodbye and it's gone. Sayonara. Just you take it down. So if you're working on an early plugin with this kind of interface, you're gonna have a lot of times you just accidentally kill your editor, which is not the best experience. Another aspect, though, is if you do external processes, you can actually have a fairly nice asynchronous environment where you send some stuff over to a process, you use libuv to kind of wait for whenever you get stuff back, and you just handle it as it comes in. If you use this Rust module, today at least, it's not as simple to do asynchronous code. I've managed to do some tricks involving like deferred functions to make it pretty asynchronous, and it supports asynchronous aspects. But it's a bit advanced and required a lot of collaboration with the author of mLua to get it to work. So at the moment, I'd say while it's doable and can give you some great performance, some tighter integration, there are definitely some negatives towards going this route. So you want to think through, what are you doing and what do you need? Can you just farm out to like some short-term programs and call it a day? Can you farm out some long-term programs and call it a day? Or do you need something like more tightly integrated like this? All right. Been doing a lot of talking. A lot of different concepts I've kind of spewed out here to kind of get familiar with different aspects we had to do, whether it's how we control the buffers or how we talk to our server and whatnot. So I want to give you just a little preview of what this looks like one more time. So we got neovim on your local machine. On the other side, example.com is a server, we got SSH, right? You love SSH, you talk to all the time. You want to connect to SSH, we say, hey, I want to connect. SSH daemon is like, what's the password? Neovim's like, I got this. Because we've got this native integration, you can say, I'm just going to use Vim's input secret, get the little asterisk as I'm typing, and tell you what my password is and send it back. And SSH is cool, you're good. The normal way this works is it's going to spawn on the remote machine that distant server that you can talk to. Once you spawn, you're done with SSH, and you're just going to connect to that server directly, that distant server. And then you can do your writing, your reading, running other programs, and even working with language servers, just like you would normally and locally, just talking with that remote server, right? So pretty straightforward. You're like, hey, I want to write files, boom, it talks to distant. I want to read files, boom, talk to distant. I want to run a remote program, boom, talks to distant. I want to work with language servers in my buffers that are remote files, boom, you got it. Now, some of you may have watched a video I had recorded a couple weeks ago, I think. We now offer an SSH mode, which is, okay, I hear you. It's hard to get extra binaries approved to run on remote machines for work, at least. I mean, if you're doing it on your own, you can do whatever you like. So, hey, what if you just don't use a different server? What if you can just use SSH, the server, and just never give up on your connection? Just use it to do all the same stuff. And now you can, right? So this is as a perspective here, whether you use distant or you use this SSH daemon, they both work the same way seamlessly. And all it requires you to saying which one you want. You want to run the remote distance server, or do you want to run purely with SSH? But it remains a constant connection, which is different from things like netrw, which farm out to SCP and SFTP to do their programs. And they have recommendations about how to configure your client, your server to maintain those connections and not get disrupted and not to constantly re-authenticate over and over. This is just straightforward. You're just using distant as an SSH client. It just talks like it would normally and does all this stuff like it would normally. All right, I'm going to show you a little bit of code. I'm not quite sure how I'm doing on time because I don't know exactly when I started, given we had this kind of sudden mix-up. So I'm going to move quickly through this because I don't know if I have like 2 minutes or if I'm over time or if I've got plenty of time. All right, so code-wise, I'm just going to show you a couple of things. One, what does it look like to configure this plugin? So I'm going to dial here. I'm going to load up a plugin and jump on down to distant. And what you'll see here is it's pretty straightforward. For the most part, all you got to do is say like, hey, I'm going to do some default settings. Maybe you define some key bindings. And then if you want to use language servers, you have to specify a little bit more. That's it. For the most part, this works out of the box. It's very minimal. The idea is that it does a lot of the work to maintain compatibility for you. And there's going to be an effort eventually to make all this LSP configuration stuff go away as well. Under the hood, I had mentioned you've got this shared library and you've got this distant.nvim plugin. Shared library is written Rust. So if I open it up, I'm going to show you a little bit of what this looks like. I had alluded to this whole in Lua module thing. This is all it looks like. I'm exporting a couple of different Lua tables. Each of those tables has Rust functions that you can call, whether it's to start a session, whether it's to like write files or do all that kind of stuff, do logging. And it's pretty darn simple. The whole Rust experience is just you have to make sure you can convert some Rust type to Lua and Lua to Rust. But to be honest, this is pretty darn easy to do. You build it, you get some shared library, you share it out, you're good to go. The core work beyond this is in the distant.nvim plugin. And this is where the meat of the things happen. So at the end of the day, it's pretty straightforward. You've got some commands you want to run. So when I did things like distant launch or whatever, those are commands. You got editor stuff like opening files and writing files, the functions, like which is a whole API and setup, right? And I'm not gonna go through all this because that goes really technical. But the gist is, I just want to reemphasize the auto commands. We only have two. We have a buff read, which, as I said, is for distant that schema, and we have a buff write. And all those do is say, hey, I want to read a file or a directory, I'm going to read it and create a buffer, or I want to write a file. And the last thing I want to show is just what it looks like when you do create one of those buffers. So I mentioned buff type. And at the end of the day, we only use two types, AC write, and we use no file, depending on if you're opening a directory or you're opening a file. The file we want to control and make sure it does a buff write. And all AC write does is say, hey, when someone's going to write this buffer, I'm just going to require them to go through that buff write command, and that's the only way things happen. So the same way that netrw does things. If you write using like one of the schemas that's got like an FTP or something, it's having a buffer that's got an AC write on it to make sure it goes through that auto command. And the no file is actually, I think, one of the most common ones you'll see. Things like, I believe, calendar.nvim and Dervish and whatnot, when you have directories, something that you don't actually want to represent as a file that you're going to edit text on, they mark it as no file. It means that it doesn't have a file, you're not going to write to it or anything like that. And beyond that, all we're doing are just doing those local buffer bindings. And so based on whether it's a file directory, I mentioned before, you can do bindings on a specific buffer So whenever you load any one of these buffers, it figures out is it a file directory and do certain bindings, whether it's navigation bindings or other associated bindings based on whether it's a file or directory, and that's it. So it's pretty straightforward stuff. You had the shared library, you load it up, you use it to talk to the server to get content, and then you use Lua to interface with Vim or neovim to do things like, hey, let me set the file type. Let me make sure the buff type's right. Let me make sure I got these other settings. But it's easier than you think. So with that, I'm going to conclude by talking about the roadmap a little bit, which is there are three main things on the roadmap for this plugin right now that are remaining. One, there's not full native shell support, and that means that you can't set up a pseudo terminal like you would with SSH or something where you open it up and you can open up Vim or something else on the remote machine and all that kind of stuff. You try to open up Vim through running a remote command right now on distant, it wouldn't work. But that's coming. That's actually a lot easier than you might think. Compatibility is a big one. There are a bunch of plugins that rely on talking to local file system stuff, doing like remote or their local programs to run. And at least with Lua plugins, it's actually pretty easy to sneakily inject and replace all the standard functions like vim.fn.whatever or vim.api.whatever. You can actually replace those temporarily. That's how we get away with doing things like the language server today. So the one idea is to build a compatibility layer where you can actually seamlessly throw in a lot of the plugins you've got that know how to work with a local file system or local programs and to say, no, do this with distant. And it just works. And it just all happens on the remote machine. So that's coming up as well. Lastly, there's some performance improvements and other tweaks, just some quality of life stuff happening. What I didn't list here is that alongside these three, there are also some open issues on neovim itself to open up some of the APIs it's got to make them a bit more easy to inject stuff. Language servers letting you say, hey, I have a language server. I don't want to spawn a local process for it and some other things. Those are also coming. But with that, it's been a lot of me talking to kind of describe the journey of, hey, setting up your buffers to be able to act as like if they're on a remote machine, even though you're working on text locally. How do we even install the library and how, like, what do we farm out to and talk to? And what does this whole like Rust integration look like? I didn't touch on a lot of the specifics there. If you're curious about like a lot of the things, like how do you do asynchronous Rust stuff and whatnot, that's a whole nother talk. But with that, we'll end with Q&A if anyone has questions. I've got some links here if you want to check out. I've got a website that I update very rarely. I've got a Twitter that I check almost never. And I got GitHub and email. And with that, I think we've reached the end of this. So I don't know if we're on time, if we're way ahead or we're way after, but we're done. Reached the end of this. So I don't know if we're on time, if we're way ahead or we're way after, we're done.
You did fantastic, Chip. Thanks for an excellent talk. I see tons and tons and tons of
I don't know if we're on time, if we're way ahead or we're way after. I'm hearing an echo, by the way. I think we're done.
You did fantastic, Chip.
Oh,
thanks for an excellent talk.
Oh,
yeah. It was okay, Prime. They couldn't hear it. Only we could hear it, but that's fine. I was hearing everything double, but chat was fine. But then you yelled that we messed up, so now they know Scuff and Stream Part 2.
Not a Scuff Stream. It's beautiful.
Someone was asking if you could just go into a little detail about, sort of your thoughts on why it's cool to have the LSP running on the server versus having it run locally. Like what's going on there? Why is that? What's going on, et cetera, et cetera.
Yeah. So for me personally, one, I do a lot of remote server work for my day job. But two, when you run a language server, depending on what you're doing and how big your code base is, it can eat up resources on your local machine. And if you don't have a super beefy machine, you can run out of resources. It can be really slow. It can kind of start to have other problems and chug pretty quickly. And so one advantage is if you throw all that stuff on a remote machine, you don't have to worry about the resourcing on your local machine. You're editing stuff. You're being a Vim, neovim wizard. You're jumping around. But all the stuff about having to index the whole project and having to do like refactorings and that kind of stuff where it takes a lot of potential processing power to do all the indexing especially, happens remotely. For some of the systems I work on, it can take like more RAM than my local machine can even have. So it's not even possible for me to run those programs locally. So that's one reason to have that going. The other reason actually that I do a lot with the local development these days is remote machine doesn't necessarily mean that it's remote as in like it's not on your computer. You could have say a Docker container. You just stick this in there, the distant binary, and you can stand up like a Python project or a Go project or whatever. And you don't have to pollute your whole main machine as you're testing stuff out. or if you have something you just want to stand up a specific environment, throw that binary in there, and then you can just act like you're working on it locally, but all the binaries and stuff you work with are in the Docker container. So those are kind of the two reasons I would do it. Would be resourcing or simplicity of your environment, keeping things separated.